All right, this is your review for Unit 1. This is going to be the review that we complete together in class. All right, looking at our first learning target where we're solving compound inequalities. In this scenario, I'm given an and inequality, so I'm going to break it up into two separate inequalities. First off, we're going to break it out with our left-hand side in our middle, so we have 5v plus 10 is less than or equal to negative 4v minus 17. I'm also going to have a second scenario where I also have that middle piece with our right-hand side. So negative 4v minus 17 is less than 9 minus 2v. I'm now going to solve both of these individually, and then I'm going to solve and graph them. So over here, I'm going to take away 10 from both sides, and I'm going to add 4v onto both sides. So we have 9v is less than or equal to negative 27. Lastly, I'm going to divide both sides by 9. So v is less than or equal to negative 3. Now on our right-hand side, I'm going to add 4v to both sides, and I'm going to subtract 9 from both sides, okay? So negative 17 minus 9 gets me negative 26 is less than 2v. Divide both sides by 2, and we get negative 13 is less than v, okay? So if I read this out loud, we are less than or equal to negative 3 and greater than negative 13. It's logical, it makes sense. I can graph both of these and satisfy both of them. Put negative 13 here, we'll put negative 3 right here. Negative 3 is going to get a closed circle because I'm or equal to, so I can't equal negative 3. Negative 13 gets an open circle. I am less than negative 3, so I'm shading less than, but I'm greater than negative 13, so I cannot go beyond him. So there we have our very first learning target. All right, we're now looking at learning target 2, and I had a request for a real-world problem in our review. So in this real-world problem, I'm given this realistic equation for estimating the height of a woman. I'm noticing that I have a margin of error of plus or minus 4 centimeters. When I'm writing an absolute value inequality, that's actually going to be on the right-hand side of my inequality. And a margin of error of plus or minus 4, that means I'm going to be within a certain value, whatever this middle height is going to be. I could be bigger than by 4 or I can be less than by 4, but I must be contained within these spots, which is why I also know that we're going to create an and inequality. So I'm going to have an absolute value inequality, and it's going to be less than or equal to 4 because I'm within 4 units, okay? But now I need to figure out what is my height within, okay? What is going to be my starting value, essentially, my middle value? So I'm actually going to take the equation they gave me, and I'm going to plug in this femur height of 48 centimeters into my formula here. When I type this in, I get 172 centimeters, okay? So now I'm going to create my h minus 172 because it's kind of like always the opposite sign inside there. Whatever my middle value is on my inequality line, he is always the opposite sign. I have a height within 4 units of 172 centimeters, okay? So now I got to create my two cases. Zoom out here to help myself get more space. First scenario, we have h minus 172 is less than or equal to 4. Less than means an and. And then we have our second scenario where we are going to flip the sign and negate. Okay? For both of these, I'm going to add 172 onto both sides of my inequality. So we have h is less than or equal to 176 centimeters. And then over here, we add 172. And we get h is greater than or equal to, oops, my apologies, I think there's an error now that I'm looking at the work on my solution guide on TestStream. It's going to be 168 centimeters, okay? All right, so now I'm going to plot these, 168, and we got 176. We can't equal these values, so I'm going to shade inside my circle. But I must lie between them, so I shade in between them. Notice that halfway between them is that 172, which is also right here inside of our absolute value inequality. Once again, this 4 is representing the units within, that I must be within 172, okay? All right, we're now looking at Learning Target 3, where I'm solving a 3x3 system. In Learning Target 3, you specifically need to show me knowledge in elimination or substitution, okay? So looking at my example that I have here, it's actually going to be an easy one to do elimination. And I'm actually going to make my pairings to eliminate the z, okay? Because I'm noticing that one of my z's has a negative coefficient. So it'd be very easy to just combine equation 1 with equation 3. As well as combining equation 2 with equation 3, because then I can eliminate them by adding. All right, so equation 1 is just x plus y plus z equals 3. And equation 3 is x plus 2y minus z equals 4. Okay? I'm going to add these two equations together. X plus x is 2x. Y plus 2y is 3y. Z plus negative z is 0, and 3 plus 4 is 7. Okay. Then over here in my second pairing, equation 2 is 2x plus y plus z equals 5. Equation 3, once again, is x plus 2y minus z equals 4. Once again, I'm going to add these two because it's very clear that my z is going to cancel out. 2x plus x is 3x. Y plus 2y is 3y. Z plus negative z cancels out, and 5 plus 4 is 9. Okay. Now I'm going to pair these two equations together, and I'm just going to rewrite 2x plus 3y equals 7 underneath the other one I created. And actually it makes sense for me to continue with elimination, because if I subtract them two, the y's will actually already cancel out. So 3x minus 2x gets me x. 3y minus 3y cancels out. 9 minus 7 equals 2. So notice I just solved for one of my values. Now I'm going to plug this 2 in, and let's just plug it into our smaller equation over here. 2 plus 2 plus 3y equals 7. So 2 times 2 is 4, plus 3y equals 7. Subtract 4 from both sides, so 3y equals 3. If we divide by 3, y is equal to 1. Now I have a value for x and a value for y. I'm going to plug these both into my very first equation. 2 plus 1 plus z equals 3. So 3 plus z equals 3, therefore z must equal 0. Okay. Now I'm going to fine-tune my answer, put it into an ordered triple. Makes my answer look very professional and clean. Please be prepared to put them in alphabetical order, x, y, z. All right, we're now going to take a look at Learning Target 4, where we're graphing a system of inequalities. All right, it's going to take me a little bit here because I struggle with graphing lines on my iPad. I'm looking at my very first equation, and I'm noticing that I actually need to put it into slope-intercept form. So to do that, I'm going to subtract the 3x from both sides. So 2y is greater than 6 minus 3x. Then I'm going to divide everything by 2, so we have y is greater than 3 minus 3 halves x. Okay. All right, so we now have our system. I'll just rewrite my second one here. Notice that both of them are going to be dashed lines because they are not or equal to's, okay? Let's zoom in here. That way I have room. Okay. All right, so the line where y is less than x, that's just going to be the line where y is equal to x, but we can't equal the line, okay? So if I draw my line very carefully here, and I'll go back and erase. This is the parent function of our linear functions where y is equal to x. I have a y-intercept of 0 and a slope of 1. Giving myself my dashed lines now. Like I said to you guys, feel free just to erase, okay? Now my other equation, if I zoom out just to show you what he was one more time, we have 3 minus 3 halves x, okay? That means I'm going to have a y-intercept of 3, draw them right there, and I'm going to go down 3 units and over 2. Down 3 units and over 2, and then I'm going to go the opposite way where I go up 3 and to the left 2, okay? And then, zoom in again to help me connect my dots. Connect these right there. And I'm just going to do this because my handwriting is starting to get sloppy. Once again, I'm going to erase some spots because these are actually not or equal to, so all the points that lie on these lines are not solutions. So now I need to figure out where am I going to shade, okay? notice that y is greater than 3 minus 3/2 x. So I'm going to shade above my blue line, okay? But y is less than x. So that means I'm going to shade below my black line, which is why I'm getting my shaded region right here where it's red, okay? I am below the black line and above the blue line. All right, so now we're going to get into our linear programming problem on the next page. All right, so now we're looking at our linear programming problem with alpha widgets and beta widgets, and we're going to let x be our alpha widgets, and we're going to let y be our beta widgets, okay? So each alpha widget gives a profit of $3, and beta widgets earn $7. So if you read the rest of this question, you're trying to maximize profit. So we're going to create our objective function right now. F of xy is equal to, we get $3 per alpha widget and $7 per beta widget. Okay, once again, I'm going to cross out that information because I've already used it. The company must manufacture at least one alpha widget, so I need to be bigger than or equal to 1, and no more than 5, okay, but I must be less than or equal to 5. Now, for the beta widgets, I cannot exceed 6, so I must be less than or equal to 6. And again, I'm noticing that I forgot to, oh no, I did underline them on task screen. Very good. Because we have to be or equal to with linear programming problems. All right, so now the tricky one. The number of beta widgets produced cannot I already did that one. Alpha widgets cannot exceed the number of beta widgets. So alpha widgets must be less than or equal to the beta widgets. So using our variables that we've already started using, x must be less than or equal to y. Okay. So now I just need to graph these inequalities. So once again, I'm going to zoom in. And actually, I want to throw it out there. Feel free to adjust the axes. If I had wanted to, I literally could have just done a y-axis here and an x-axis here, okay? Feel free to do that on your own paper. All right, so we have the line where y is equal to x, because that's our exceeding of our alpha to beta widgets. So we're going to draw it right here, okay? We know our alpha widgets are between 1 and 5, so I'm drawing 1, 2, 3, 4, and oops, I lost count. 3, 4, and 5. Here are the limitations on alpha widgets. And now I need my beta widgets. Betas, they must be below 6. So 1, 2, 3, 4, 5, and 6, okay? All right, so now I need to find the shaded region. And it's going to lie above our line of y is x, okay, because beta should be more than alpha, okay? So then our vertices, okay? Right here, we are intersecting at 1, 1. Right here, we are intersecting at 5, 5. There, we are intersecting at 5, 6. And right here, we are at 1, 6. Okay, so now I'm going to take all these coordinates and I'm going to plug them into our objective function. So we start off with 1, 1. 3 times 1 plus 7 times 1 gets us 10. Next, if we do 3 times 1 plus 7 times 6, that gets us 45. 3 times 5 plus 7 times 5, that gets us 50. And lastly, 3 times 5 plus 7 times 6 gets us $57, okay? So what this means is we must make 5 alphas and we must make 6 betas in order to maximize our profit. All right, so now we're going to scroll down to our matrix expression, and I'm reminding you of remembering your order of operations. So in this problem, we must first multiply before we add. So I'm just going to carry down this first matrix because I'm actually not using him yet. I must first complete this matrix multiplication. So I have a 2 by 2 being multiplied by a 2 by 3. The number of columns of my first one is equal to the number of rows of my second one, so they can be multiplied. And they are going to produce a 2 by 3 matrix. So 2 rows, 3 columns. Okay, so let's multiply. Row 1 times column 1 is going to produce the row 1, column 1 position. Negative 1 times 0 is 0, plus 3 times 1, which is 3. Next, we're going to do row 1 times column 2. Negative 1 times negative 6 is 6, plus 3 times 1, we get 9. Now we have row 1 times column 3. Negative 1 times negative 1 is 1, plus 3 times 4, that's going to be 13. Now we're moving into row 2. 6 times 0 plus 1 times 1 is 1. Then we do row 2 times column 2. 6 times negative 6 is negative 36, plus 1 is going to be negative 35. And now our last one, we have row 2 times column 3. 6 times negative 1 is negative 6, plus 4 is going to be negative 2. Now I'm going to add these two together, and we're just going to add their corresponding elements. 3 plus 3 is 6. 1 plus 9 is 10. 3 plus 13 is 16. 0 plus 1 is 1. 5 plus negative 35 is negative 30. And negative 3 plus negative 2 is negative 5. All right, so now we're going to take a look at this real-world example here, okay? And I have this matrix, and I have a matrix that I actually need to create, which is going to contain all my prices, okay? So first things first, to recognize the fact that this one is a 4 by a 3, okay? And so when I multiply it, if I multiply it on this side to this side, it needs to have a 3 row. Well, the 3 row on this side will not work simply because I have 4 prices given in this problem. So I need to be focusing on something to multiply on this side that's going to have 4 columns, okay? So we're going to have 1 row and 4 columns because it's going to contain each of the prices, okay? The other thing to notice is the fact that I only actually need the information for Saturday. So I'm only going to turn this into a 4 by a 1, okay? Make my life a little bit easier here. So $3 for every burger, $4 for every hot dog, $2 for every fry, and 50 cents for every drink, being multiplied by this lovely column matrix of 138, 104, 235, and 306. Notice how the price for the burgers is going to get multiplied by the number of the burgers when we start to do matrix multiplication here. Same thing goes for the number $4 for every hot dog. It's going to get multiplied by the 104 hot dogs, okay? So when we start to multiply it out, I'll alternate my colors, plus 2 times 235, plus 50 cents times every 306 drinks. I have to go on to a different line here. If I type this all in here, I'm actually going to get A as my answer, $1,453. All right, in Learning Target 8, we're evaluating determinants, and my strategy for 3 by 3s, always rewrite the first 2 columns. Just because I have variables, don't get afraid. It's still going to be treated the exact same way. First off, my downward diagonals. 0 times C times Y is 0. A times D times 0 is 0. B times 0 times X is 0. You catching on as to what's happening? You can still treat it exactly the same. 0 times C times B is 0. X times D times 0 is 0, and Y times 0 times A is 0. If we do our downward diagonal of 0 minus our upward diagonal of 0, 0 minus 0 is 0. All right, let's now take a look at our inverse, okay? To find the inverse of a matrix, I must first find its determinant, okay? So the determinant is going to be equal to 3 times 6 is 18, minus negative 4 times negative 2 is 8. So our determinant is equal to 10, okay? So I'm going to divide everything by 10, but I first must flip around a few things. So the 6 and the 3 are going to change locations, and the negative 4 and the negative 2 are going to flip their signs. Now I would like for you to go a step further, and we're going to divide everything by 10, okay, and then simplify our fractions. So 1/10 of 6, that's 6 divided by 10, will simplify to 3/5. 1/10 of 2, that simplifies to 1/5. 1/10 of 4, that'll simplify to 2/5. And 1/10 of 3 is just going to be 3/10, and that's as simple as this one will get. All right, so now we're looking at our Learning Target 10 example, and I do have you trying both methods just to practice both methods of using inverses and Cramer's rule. First off, let's create our matrix equation. we have our coefficient matrix where we have a column for our x coefficients and a column for our y coefficients. So our x's have coefficients of 1 and -4. Our y's have coefficients of -5 and -2. We're essentially multiplying our coefficients by our variables x and y. And it's going to be set equal to our solutions, okay, -5 and 20. All right, let's first use Cramer's rule. For Cramer's rule, we need to figure out determinant D, okay? Determinant D is going to be equal to our downward diagonals. 1 times -2 is -2, minus our upward diagonal. -4 times -5 is 20. So our determinant D is going to be -22, okay? Now determinant dx, okay, that's going to be the determinant where I change the first column, which is my x coefficients, with our solutions, okay? And then my y column is just going to stay the same, okay? So we have -5 times -2, which is 10, minus 20 times -5. So that's going to be minus a negative, and 20 times 5 is -100. Oops, I lost my pen there for a second, okay? So we have 10 minus -100, which is 110. So to figure out a value for x, we're going to take 110 and divide it by -22. And 110 divided by -22 is -5. I'm now going to take this value for x and plug it into my first equation to solve for y. So -5 minus 5y equals -5. All right, so then let's add 5 onto both sides in order to isolate our variable. So we get -5y is equal to 0, which is why y is equal to 0, okay? But I also asked us to use matrix inverses. Remember when I multiply the left-hand sides by my inverse, that's going to produce our identity matrix multiplied by our variables, okay? Now we've already found out the determinant, so that's why part of our job is already done. Now the other component to finding the inverse is flipping our downward diagonals locations and changing the sign of our upward, okay? It's being multiplied by our solutions. All right, so we have x, y, it's going to be equal to, I'm not going to divide by -22 yet. It's actually made more work if I did it sooner than later. So row times column. -2 times -5 is 10, plus 5 times 20 is 110. Notice how those ended up being the same. Now we have 4, 1 times -5, 20. So 4 times -5 is -20, plus 1 times 20 is 0. When we distribute in our scalar of dividing by -22, we get the same exact solutions of -5 and 0.